Welcome back to Miss Eddie's Math Movies, where it's a cute to be a square. Today's lesson is 11.4, Arcs and Chords. By the end of the lesson, you'll be able to use properties of chords to find measures in circles. The first property we're going to learn is about the diameter. So when you have a diameter of a circle and it's perpendicular, which means 90 degrees, so if it's perpendicular to a chord, notice there's the chord right there. There's the diameter. Then it bisects. Remember, bisects means cut in half. Diameter bisects the chord and the arc. So if you see a diameter that's perpendicular to a chord, the chord gets cut in half and the arc gets cut in half. So if BG is perpendicular to DF. And imagine if it's not perpendicular. Let's look at an example where it's not perpendicular. So here's a chord, and here's a diameter that's not perpendicular. Notice it's not cutting it in half at all. So when you see it's perpendicular, then you know it's also cutting it in half. Oh, here we go. Name the diameter. We just did. That was BG. Name the chord that got cut in half. DF. Name the arc that got cut in half. Well, this arc right here, DF, but we put an arc above it. Draw the diagram, and we already did this up there. Mark all congruent segments and arcs. We mark those segments were congruent, and we mark those arcs were congruent. So in circle C, the diameter, AF, is perpendicular to BD. So find the length of BD. Well, so we know it's perpendicular, it's a diameter, so it's cutting this chord in half. So if this is 5, then this half must be 5. So what does it want from us? Let's find the length of BD. That means BD is 5 plus 5. BD is 10. Name the parts that the diameter bisects in example 1. Okay, so what chord got cut in half? The chord was, if you see here, the chord was DB, and the arc is also DB. So DB got cut in half, and arc DB got cut in half. So now what's congruent? Well, we got to name the two parts. So DE and EB are equal. We're going to write that. And arc DF and arc FB. Let's see if we can remember that. DE is congruent to DB. And the arcs were arc DF and arc DFB. I'm going to go back and check on that. I think it's F for BF. So I said DE and DB, yep, DE and EB, and DF, FB. DF and FB. Yep, that's correct. All right, I want you to go ahead and do this now. You're finding the length of JM. Notice here's JM right here. And SR. Please notice that SR is the whole thing. We have another property of chords. It's kind of like the reverse of what we just did. If one chord is perpendicular and bisecting another chord, then the first is a diameter. So if you see bisecting and perpendicular, it has to be a diameter. Suppose an archaeologist finds part of a circular plate. Show how to reconstruct the original shape of the plate. All right, first we're going to draw two chords. What's going to happen is we're going to find the diameter, and that's going to give us the center, and then we know how big the plate was. So we're going to cut these in half and make it perpendicular. So cut that chord in half, make it perpendicular. Cut that chord in half, make it perpendicular. Right, we know that this is a diameter and this is a diameter, which means this is the center of the circle. So now we can use a compass to draw the rest of the plate because now we know where the center is. Why does the method in example 2 work? Because the diameters intersect at the center. More properties about the length of chords and arcs. Notice we're not doing anything with angles, we're just doing it with length. If two chords are congruent, then their blank are congruent. Okay. If there's two chords that are congruent, then their corresponding arcs. So if this chord equals this chord, that must mean this arc is equal to this arc. So if AB is equal to DC, then arc AB is equal to arc DC. And the reverse is true. If the arcs are congruent, then their corresponding chords are congruent. So if you see two arcs that are equal, then the chords that go with them, the segments that go with them, are equal. What is the relationship between these two? Well, notice it's just switched around. That's called converse. They are conversive, not the shoe. When you switch it, it's a converse. Find the value of x. Well, I see two chords that are equal. If two chords are equal, two arcs are equal, and the angle is equal to the arc. So this means x equals 60. Because we have equal chords, which gives us equal arcs, which gives us equal angles. Here, I see equal angles and equal arcs. And if we have equal arcs, then we have equal chords. So this chord is going to be the same as this chord, which means x equals 3. All right, down here, you need to find the value of x. Do these now. This is M cubed, signing out.